The goal of this lesson is to teach you how to find prime factorizations and least common multiples. So hopefully those are two skills that you're able to have by the end of this lesson. Now, prime factorizations are tools that we use in order to find least common multiples, and the reason we want to know least common multiples is it's a practice that is very often used later down in algebra in things like adding and subtracting fractions and things of that nature. So for now, we're just going to give you the foundations on how to find these least common multiples. So the first thing I need to teach you is what factors are. So definition of a factor: if A multiplied by B is equal to M, then A and B are factors of M. So an example of this would be, say, the number 72. You just got to think of, say 72 is our M, we got to find the A's and B's that multiply to make M. So examples of this would be 1 times 72, 2 times 36, let's see here, 3 times 24, and so many other factors like that. Now, again, 1 and 72 are factors of 72. 2 and 36 are factors of 72. 3 and 24 are factors of 72. And I guess we could finish this list out. There's 4 multiplied by, let's see here off the top of my head here, 18. There's 6 and 12, and then finally 8 times 9. So these are all the factors of 72. Again, 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. And again, you could do this with any number. And again, the factors are just the two numbers that multiply together to give you that number. So these are what factors are. The next definition we need to know is what prime numbers are. And the definition of a prime number is a counting number whose only factors are 1 and itself. So as we see in this last example, 72 has the factor of 1 and itself, 72, but it also has many other factors. So for that reason, 72 would not be a prime number because it has more factors than just 1 and itself. However, some examples of numbers that are prime are, say, 2, because what gives us 2? Well, it's the factors 1 and 2, but there are no other factors that give us 2. Similar, 3. 1 times 3 give us 3, but nothing else can give us that. 5, because 1 times 5. Another would be 7. Let's see here, 11, 13, 17, 19, and so on. There are many, many different prime numbers. And again, these numbers are prime simply because their only factors are 1 in themselves. There's no other numbers that you can multiply to give us 7 or 11 or 13 or 17 or 19. So these numbers are what we call prime because, again, they only have factors of 1 in themselves. So then if those numbers are prime, then what are the other numbers called? Well, these are called composite numbers. And a composite number is a counting number that has a factor other than 1 in itself. So like we said earlier, 72 is an example of a composite number because, yes, it has factors of 1 in itself, but it also has many other factors that, we can go back and review over here. So 72 would be an example of a prime number. But there are many other prime numbers. Really, many other composite numbers. Any other numbers that aren't prime are composite. So, going down the list, the smallest one is 4. Then there's also 6, because 4 is 2 times 2. 6 is 2 times 3. Then you have 8, 9, 10, 12, and so on. And again, these numbers are composite because they have factors that are different than 1 in itself. So why do we want to know the difference between prime numbers and composite numbers? Well, it's so that we can find our prime factorization. And now this is kind of an important concept. So a prime factorization is the product of prime numbers which make a larger number. So the idea here is every single number there is can be broken down into a set of prime numbers, and that set of prime numbers is the prime factorization, and this is true for any number. So let's just go through an example of a prime factorization and how we found it. So let's say, for example, we have the number 48, and you were asked to find the prime factorization of 48. Again, break 48 down into a string of prime numbers. Well, the first step is you have to find all of its original factors. So again, what are the factors of 48? Well, there's 1 and 48. There's 2 and 24. There's 3 and 16. There's 4 and 12. Then there's 6 and 8. So these are all of the factors of 48. So now you can break 48 down by any one of these numbers. And how I like to do it, I usually like to start with 2, but you could literally choose any of these numbers up here. So step 1, choose one of the numbers to break it down by. I'm going to break it down by 2. So what are the factors that make 48 with 2? Well, it's 2 and 24. So that is the first step. Step 2, repeat until you've broken everything down into prime numbers. And you see, from each branch, I stop when I hit a prime number, which 2 are prime numbers and 3. And now we see neither of these numbers can be broken down at all anymore, so I stop right there. So that is step 2, breaking it down into prime numbers. The third step is identify those prime numbers. So 2, 2, 2, 2, and 3. So these are our prime numbers. So then the fourth step, line them out. So 2, 2, 2, 2, and 3. So if we notice, if we multiply all these numbers out, it will equal 48. And we also notice that this is a string of only prime numbers. So therefore, the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. Like I said, I chose the number 2, but you could choose any number. You know, you could have also done 8 and 6 and broken those numbers down as well. And you'd find that you would still get the exact same prime factorization. So again, every number has only one prime factorization. You can find it multiple ways, but that is the steps in how to find that prime factorization. So what I'm going to do is give you guys an example of a prime factorization you guys can work out for yourself. So let's try the number 80. Okay, so step 1, let's break it down. Again, I like to go by 2s. Okay, so that was the first step, find its prime factorizations. The next step, identify all of your prime numbers. The third step, write them out. So the prime factorization of 80 is 2 times 2 times 2 times 5. So hopefully now you're able to find prime factorizations of any numbers. So again, now why do we care about prime factorizations? Well, we use them in order to find least common multiples, which, like I said, will come up in later lessons when it comes to fractions and things of that nature. So what is a least common multiple? Well, a least common multiple of two numbers is the smallest number, which is a multiple of both numbers. So again, if we remember what multiples are, they are when you multiply a number by a counting number that is a multiple. So if you have two different numbers and you want to find the smallest number that they're both multiples of, well, you are finding their least common multiple. So how do we find this least common multiple? Well, let's just go through an example of it. So say we're working with the numbers 12 and 18. Again, our goal here is to find the smallest multiple that each number has in common. Again, the smallest least that they both have in common that is a multiple, the least common multiple. So the first step is find the prime factorization of each number. So you'll do so. So for 12 is equal to 2 times 2 times 3, and 18 is equal to 2 times 3 times 3. So again, step 1, find the prime factorization of each number. Step 2, you have to line these numbers up in a certain way, and I'll show you how to do that right now. So step 2, how you want to line them up is you want to line up common prime numbers. So 2 is a common prime number, but then with 18, since I have 2 3s, I'm going to line them up like this because I can't line up a 3 next to a 2 because they're not the same number. So step 2 is line them up in this way. Step 3 is drop down those similar numbers. So these just become a 2, 2, 3, and 3. So that is step 3. And step 4, multiply them all together. So 2 times 2, 2 times 3 times 3. Well, that is equal to 2 times 2 is 4 times 3 is 12 times 3 is 36. And that is our answer. So if you were asked to find the least common multiple of 12 and 18, it would equal 36. And again, let's just go through that again. So what are the multiples of 12? Well, 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. No, the 18, 18 times 1 is 18. 18 times 2 is 36. So this is a way of verifying it. So you see that the smallest multiple that they both go into is the number 36. And we prove that by going through our steps, or we found it by going through our steps up here, and we proved it just by this simple table right here. So that is how you find the least common multiple of a number. So I'm going to give you guys an example to work on your own and see how you do. The example is find the least common multiple of the numbers 9 and 12. And you can work on that right now. Okay, so let's go through it. So step 1 is find the prime factorizations. 2 and 6, excuse me. 2 and 3. Step 2, line them up. So 9 is equal to 3 times 3. 12 is equal to 3 times 2 times 2. Step 3, drop them down. 3, 2, 2. Step 4, multiply them out. 3 times 3 times 2 times 2. 3 times 3 is 9, times 2 is 18, times 2 is 36. So our least common multiple of 9 and 12 is 36. Again, we can confirm that by 9 times 1 is 9, times 2 is 18, times 3 is 27, 9 times 4 is 36, 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36. So, right there, again, we verified that the least common multiple of 9 and 12 is the number 36.